Okay, in question 2 then, we can label these two angles as theta, each one. Can also label this angle as the Greek letter P. And then let's see what relationships we have. Theta must be equal to beta plus P, because this external angle adds up to the sum of these two interior angles. And then if we use the same rule, using this theta as an external angle, we can see that theta is also equal to alpha plus P. What does that tell us then? Well, it tells us that alpha must be equal to beta. So if we know we've got an isosceles triangle, we can call this alpha. By using the same rule as we did in question 2, the angle BCD must be 2 alpha. And because we've got two congruent triangles, we can also say that this angle is 2 alpha. And then by looking along at this straight line, we can see that 3 alpha is equal to 90, alpha is equal to 30. Okay, the first thing to note then is we've got a right angle triangle here, meaning we've got two congruent triangles by angle side angle, because we've got alpha, this shared side, and this angle here. If they're congruent, it means that BD is equal to DC. And then looking at the other triangle, BEA, we can see again that that is congruent to the other two triangles mentioned before. So we can see that BEA is congruent to ADB, again by side, and then, again by angle, side, and then angle. Because we know this must be beta here, and in the same way we must have beta here. So if they're congruent, that means that AE must then be equal to BD and equal to DC. So AE divided by BC must be 1 over 2. In 5 then we've got two isosceles triangle. Well, we've got one isosceles triangle. AD is equal to BE. So that means that this angle is 55, this angle is 55. We can also see then that these two triangles are congruent, and that is by side, angle, side. If they're congruent, then it means that DE is going to be equal, let me use a different symbol, DE is going to be equal to DF, meaning that DFE is isosceles and that X must be equal to Z. Not only that, if we label these angles, let's say alpha and beta, and this is alpha and beta, we can see then that alpha plus beta plus 55 is 180. And so if we look here, we've got alpha plus beta, so that means that y must equal 55. And then x must be equal to, well, z, and both of them are equal to 180 minus 55, all divided by 2, which comes out to 62.5 degrees. 9, we've got an isosceles triangle here, so we can label this B and beta. Another isosceles triangle at the top, so theta and theta. And then let's have a look at any relationships we've got. Well, again we've got this external angle, which is equal to the sum of those two interior angles, so theta equals to beta. We also know then, looking here, that theta plus beta must be equal to 60. And so If theta is equal to 2 beta, then 2 beta plus beta equals 60, and beta must be equal to 20. In addition to that, we know that we have an isosceles triangle. AB is equal to AC, so this angle here must also be alpha plus beta. And if we look at the triangle BEC, we can see that alpha plus beta plus alpha must be equal to 60. If beta is 20, then 2 alpha is 40, and alpha is also 20. So in question 13, we're told AB equals AC, AB equals AC, BD equals CE, with these two. And we can see we've got two congruent triangles. BAD is congruent to CAE because of side, angle, side. If they're congruent, then it means that these sides, AD and AE, are congruent, which means that we've got an isosceles triangle and that this angle is also alpha. We also know then that these two angles are congruent, so if you label that each one of those X, and then let's label the remaining one in the middle here, let's call that Y. And then if we look at ABC, which is an isosceles triangle, we can see that X plus Y must be equal to 180 minus 2 times 80, which is 20. So if X plus Y is equal to 20, then looking at ADE, alpha must be equal to 80. 15, it's a complicated one, says pick a point D, so let's call this D, inside the interior region of ABC such that DBC is theta, so let's just draw that. DBC is theta and DCB is alpha. Super. Then in triangle AEC, which is outside, let's draw that, okay, AEC. There we go. CAE is alpha and ACE is, sorry, I said theta before, this one's alpha. And what we should notice then is we've got two congruent triangles. BDC is congruent to AEC because we've got angle, side, angle. By ASA. I could actually change my diagram just a little bit to make it look a bit more accurate. There we go. That's point E. Then it says find MDEC. So DEC. Going to be, if we draw a line to DE, this angle here. Well, if we've got two congruent triangles, then that means that DC is equal to EC. And that means that this angle here, if we call it, they call it X, so let's do that, X, means we've got X over here as well because we've got an isosceles triangle. Then if you look at this angle here, because ABC is equilateral, this angle here must be 60 minus alpha. And then if we look at triangle DEC, we can see that this whole angle here must equal 60, and therefore X must also equal 60.